In number 5, we're just trying to use identities to rewrite each expression, and we want to do it so that we just have a single trig function. The idea behind this is to look at the pattern and see if this matches one of our identities. This pattern where we have cosine squared minus sine squared, that matches one of our double angle identities. It's one of the ones for cosine. Here's the identity that we would be using. Cosine of 2a equals cosine squared a minus sine squared a. What we have matches the right side of this. That means that for our a we would have x over 6. Rewrite this, we're going to write this as just cosine of 2a. If a is x over 6, then 2a is going to be 2 times that. That would reduce to x over 3. So we could rewrite this side as the cosine of x over 3. And that's as simple as we could get it. For this one, we want to do the same thing, and that is to match this to one of our identities. This looks like one of our half angle identities because it has the plus or minus and the square root. Since it has the plus inside of here, it would be the half angle identity for cosine. That one is that the cosine of a over 2 is plus or minus the square root of 1 plus cosine a over 2. If we compare this to what we have over here, that means our a would equal 4x. When we put the a into this side, we would have 4x in place of the a. 4x over 2 is going to simplify to just 2x. Now we're going to find the exact values of sine 2 theta and cosine 2 theta. All we know so far is that sine of theta is 24 over 25 and that the tangent of theta is less than 0. And right away what this tells us, if the tangent of theta is negative, since tangent is sine over cosine, that means that our cosine of theta would have to be negative. So if we're finding a value for cosine, we know it would have to be the negative value. When we do the cosine of 2 theta, we can use one of the identities that only involves the sine of theta. But for the sine of 2 theta, the identity for that one uses both sine and cosine. That means that we're going to need to know both sine and cosine of theta. So let's start by finding the cosine of theta. We know that sine theta is 24 over 25. So here's where we're going to use our Pythagorean identity. We've got the sine of theta is 24 over 25. We're going to plug that in here and square it. We want to solve this for cosine squared first. 24 over 25 squared is going to be 576 over 625. We're going to subtract that from each side. When we do that and get a common denominator, we're going to end up with 49 over 625. Now we want to solve this for cosine. We know that the cosine is going to be negative. We're going to take the square root of this side, and then we're going to take the negative value of that. So the square root of 49 is 7. The square root of 625 is 25. There's our value for cosine. Now we can go back and use our double angle identity for sine and find the sine of 2 theta. We're just going to plug in our values for sine theta and cosine theta. And then if we multiply this out, we're going to end up with negative 336 over 625. Now to find the cosine of 2 theta, we've got our choice of 3 different identities that we could use for that. It really doesn't matter here which one we choose. I'm going to choose the one that just involves the sine. That would be 1 minus 2 sine squared theta. I'm going to put in my 24 over 25 here for the sine of theta and square it. That gives me 576 over 625. If I multiply that by 2 and then subtract that from 1, I'm going to end up with negative 527 over 625. Let's do number 7. In this one we're using the sum identities for sine and cosine. Both of these identities use both sine and cosine of x and sine and cosine of y. What we have in this problem is only the sine of x and the cosine of y. What we need to do first is find the cosine of x and the sine of y. Let's start by finding the cosine of x. For both of these we're going to use that first Pythagorean identity which says sine squared plus cosine squared equals 1. For this one we can plug in the 7 over 25 for the sine of x and square that. When we square this we get 49 over 625. We're going to subtract that from both sides and then get a common denominator over here. And that's going to give us 576 over 625. Now we want to take the square root of each side, so we need to figure out whether cosine would be positive or negative. Up here it says that x is in quadrant 2. In quadrant 2, cosine is negative. That means we're going to take the negative value of our square root, and that would give us negative 24 over 25. Now let's do the same thing and find the sine of y. We're going to use the same Pythagorean identity. We have sine squared of y plus cosine squared of y equals 1. This time we're plugging in our value for cosine of y and squaring it. That would give us 64 over 289. Then we're going to subtract that from 1. That would give us 225 over 289. Now we want to solve this for sine of y. When we look at our information up here, it says y is in quadrant 3. That means sine of y is going to be negative. We're going to take the square root of this and then take the negative value. That's going to give us negative 15 over 17. So now we have all four values that we need. We have these two and these two. To do cosine of x plus y, here's the identity. This would be cosine x times cosine y minus sine x times sine y. Then we're just going to plug in the values that we have. Cosine of x is negative 24 over 25. Cosine of y, we were given, is negative 8 over 17. Sine of x, we were given, is 7 over 25. And sine of y is negative 15 over 17. When we multiply these two, we get 192 over 425. When we multiply these two, we end up with a positive 105 over 425. Adding those two together, we get 297 over 425 for the cosine of x plus y. We can do the same thing for the sine of x plus y. The identity for this would be sine x cosine y plus cosine x times sine y. Then we're going to plug in our four values. Sine of x is 7 over 25. Cosine of y is negative 8 over 17. Cosine of x is negative 24 over 25, and the sine of y is negative 15 over 17. We multiply these two together, we get 56 over 425. When we multiply these two together, we get a positive 360 over 425. Combining these two, we get 304 over 425. Now let's look at number 8. In this one, we're trying to find exact values for sine of theta over 2 and cosine of theta over 2. We know the value for cosine of theta, and we know what quadrant theta is in. What we'll need to know for these formulas is what quadrant theta over 2 will be in, so we know whether to use the positive value or the negative value. If we want to figure out theta over 2, we can just take this inequality and divide all three parts by 2. If we divide 3 pi over 2 by 2, and theta by 2, and 2 pi by 2, that's going to give us 3 pi over 4. And on this end, it's going to give us pi. If our angle is between 3 pi over 4 and pi, that would be in the second quadrant. That means that sine of theta over 2 is positive, and cosine of theta over 2 is going to be, now we're going to use our half angle identities. For sine, we have plus or minus 1 minus cosine of a over 2. We just figured out that the sign that we're looking for is going to be positive, so our sine of theta over 2 would be positive square root of 1 minus 1/3 over 2. That would give us 2/3 over 2, which would simplify to the square root of 1/3. We could simplify that just a little bit more and make it 1 over the square root of 3. Then for our cosine, this time we know that cosine is going to be negative, and the only difference between the identities is that here we have a plus instead of a minus. We're going to plug in 1/3 for the cosine of a, and then simplify this. This would be 4/3 on the top. We can simplify this a little bit more. That's going to be the square root of 2/3, or we could write it as negative square root of 2 over the square root of 3.